Hey Huskies, welcome to section 2.3 on piecewise defined functions. It's one of my favorite topics. So today we're going to talk about piecewise functions, and really a piecewise function is taking different functions and putting them together in one graph, and we really restrict our domain, and which ends up restricting your range as well. So in the first video we're going to break this up into a few different videos, but we're going to graph piecewise defined functions. We're going to look at the domains. We're going to use a graph to find the domain and range, and then use a formula to find domain and range of a function. So let's get started. And so when you look at this example, you can see here, if I'm not in the way, there we go. Here is our piecewise defined function, and they make it look like cases here. So you have different functions, and pay attention to some of the things. On the left here, we really have the two functions or functions we're graphing, and then on the right here we have our domain restrictions. Okay, remember that when you have a line underneath for an inequality, we're going to fill in the dot, and when you have no line under the inequality, you're going to have an open dot. So here's our two functions, and we're going to plot our first function as x squared. Okay, and notice our values that we're going to use are less than or equal to 2. So essentially what you're doing is you're making a table of values. You're plugging 2, 1, 0, -1, -2, and so on into this x squared equation and just evaluating. So I'm going to go ahead and fill the top up here. So I have my graph. So 1, 2, 3, 4, 5. I think we can just go to there and we're fine. If I plug in 2 to x squared, I get x squared. And so that's going to be 4. And notice I would not plug 2 into the bottom function, okay, because the bottom function is greater than 2. You don't include the 2 there, so you would use the top function, okay? So let's plug in 1. 1 squared is 1, so I'll go halfway. Here's 1. If I plug in 0, I get 0 squared, which is 0. If I plug in -1, I get 1. And if I plug in -2, I get 4. So here is my graph of my parabola. And I'll draw the arrow going that way. I do not draw the arrow where 2 is because that's where the function stops. That's all its domain is restricted to. That's where we go. So the second one I'll draw in red, and that's 6 minus x squared. Or excuse me, 6 minus x for values that are greater than 2. Now I'm going to plug into that function, but I'm going to leave it as an open circle. So if I plug in 2, 6 minus 2 is 4. So look, oh, they overlap. So you could put, I usually just put a little circle around it like that because that's my other graph. Okay, they actually share the same value. And let's plug in another value that's greater than 2. Let's try 3. 6 minus 3 is 3. So we plug in 3. We get 3, which is right here. Let's plug in 4. 6 minus 4 is 2. So 6 minus 4 is 2. And I've got enough points to graph this line. So I'll go ahead and should straighten out for me. There we go. And that is our piecewise function. In this case, it was two different graphs that we did. And so you can see here that it's two different pieces. And you got to be really careful. You don't have to do the open circle here. I always do. So if I'm grading or I understand that one of those is not included there. So let's move on to our next example. Okay, graph y equals g of x given by the following formula. So you have g of x here. There we go. Sorry, a little delay. Here's g of x, x plus 1 for, there's your domain, and g of x equals 1 for x is greater than 2. Now, the second one of this piecewise is much easier. Look at here. It says, no matter what x is, if it's greater than 2, your output's going to be 1. So when you see no variable there, it's a constant. It's just a horizontal line. Okay, so let's start with that one. I'm going to go ahead and graph. Here's our line 1. So 1, 2, 3, 4. So anything greater than 2, it's 1. So here's 2. So I'm going to do an open circle here because I can't include 2, but I notice that I start there. And greater than 2 goes this way. So that blue graph is done. Now we're looking at x plus 1. And again, I always use different colors so I can see. X plus 1 for anything x is less than or equal to 2. So let's plug in 2. 2 plus 1. 2 plus 1 is 3. So we plug in 2, we get 3, which would be right here. Close that circle off. Okay, let's plug in 0. 0 plus 1 is 1 right there. And I have enough. I could do -1. -1 plus 1 is 0. So then I can go ahead and draw my line to the left. And there is my piecewise function. So I like it 2 different colors there. And you can see we have pieces of different graphs coming together. They can be lines, they can be parabolas, they can be a lot of different things. So if you have any questions or comments on how to graph those piecewise functions, you can go ahead and type them below. We'll see you next time.